Go weekly contest 502. I don't want to use my buds.
It's better. I hope there is no echo. This is an experiment with my sound quality. Okay. Weekly contest 502. Let's go. 5 seconds. Join. Cool. Check existence integer difference. Absolute difference between this is at most to otherwise return false. Okay. For int I is equal to 0, I is less than s dot size minus 1. Say int n is equal to s dot size I plus plus if s of I abs of s of I minus s of I plus 1 is greater than 2, then return false, else return true. True and false, right? Let's move to the second question. Count kth root in a range. You are given three integer L, R, and K, and integer y is said to be a perfect kth root if there exists x such that y is equal to this. Return the number of integer y in the range that a perfect root of k is. Okay, and this is this, and this is this. So what we can do is we can do brute force here. And what's the time complexity of that? Okay, y should be in the range of this, right? Not x. So there exists an integer x such that what we can do is, I'm thinking something of binary search. We'll find the largest x, we find the what we want, we find the largest y and we find the smallest y. How does it looks? Let's say 1 to the power k, 2 to the power k, 3 to the power k. So I want x to the power k is greater than equal to L and x to the power k is less than equal to R, right? So what x should be? So if I take log both the side, log of x to the power k is greater than equal to log of L. So k log x is greater than equal to log L. So log x upon log y is equal to 1 by k. So log x is equal to log y by k. No, log L by k. Right. X is equal to e to the power log L by k. But it is visible in code. Int left is equal to e log L by k. Or we can think something better. We can use binary search, right? Yeah, find the smallest x. Int start is equal to 1. Start is equal to 0. Int end is equal to, what is the n? Yeah, 1e9. While start is less than equal to end, mid is equal to start plus end minus start by 2. If mid into mid, no, power, right? And what's the x to the power n? N minus minus answer into x, return answer. If power of mid into x is greater than equal to L, left is equal to -1, then left is equal to mid and end is equal to mid -1, else start is equal to mid plus 1. So we are trying to find the left boundary, right? Similarly, we'll find right boundary also. While again start is 0 and is equal to 1e9, while start is less than equal to end, copy this such things, right? And this is less than equal to r, then start is equal to mid plus 1 and is equal to mid minus 1 and right is equal to mid. Yeah, and we return right minus left plus 1. Okay, so this is long, this is long, Okay, make it 6, make it 3, not even 3, 2, 1. Wait a minute. See out X and N. What's going what's going on here? Just normal power, right? But I am not sure. 3 works, right? What we can do here is, let's make it 9. Let's make it 9 here also. If answer is greater than 1E9, return answer. I want answer into X is less than equal to 1E9. The answer is less than equal to 1E9 by X. If answer is greater than 1E9 by X, return answer. This should work, right? Or I'm missing any edge cases here. Let me test. L say 0, R say 1E9, K say 30. 1E9 is okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. We are getting answer. We got our answer, right? Wait. What I 1, 2, 3, 4, 5, 6, 7, 8, 9. Is this correct? 0 is there, 1 to the power 30. 1 is there, 2 to the power 30. This is correct, I guess. 2 to the power 30 is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1E9. It's not true, right? Yes. Let's move to the third question then. Largest vocal value in a matrix 2. Largest vocal value to find. Okay. See, constraint is pretty slow. Constraint are pretty low here. Okay, let's read the question now. You are given an n cross m integer matrix containing non-negative integer. A non-zero row call check the cell near it as follow. Let x is this. Consider every cell within x row and x column of this. Ignore cells that are outside the matrix. Ignore the cell where both the row distance and column distance are exactly x. A cell row column is a local minimum if it is a non-zero and no considering cell has the value greater than x. Written in an integer denoting the number of local maxima in a mini. Okay, this that means 2 1 2 1 2 1. And how 1, how they have made this? See, 1 2 I got it. 1 2 1 2 1 2. What about this? 1 2 1 1 2 1 2. Wait. Consider every cell within x row and x row. Okay. Row 1 2 1 2. Column is 1 2. But I'm not getting why we have not taken this cells. Check the cell near as the follow. Let x is equal to this. Consider every cell within the x row and x column of this x row. 4 cell 3 3 x equal. The highlighted cell are considered cell within x row and x column of 3 comma 3. How? Wait a minute. Ignore cells that are outside the matrix. Ignore the cell where both rows and column number are exactly okay. Okay, these are exactly 1 comma 1. Column and distance are exactly x. How we calculate the distance now? What they want to check is, let me draw a few things. 1 2 3 and 4. Only the cell with value 4 is a local maximum. Every other non-zero cell are considered 4, right? Okay, not much idea here. 1 0 1 0 1 0 1 0 1. So for this, we're checking into this. For this, we're checking into this. Okay. For this, we're checking. How we have what to ignore? I'm not sure. Like what to ignore. It's a brute force, right? People even started coding this. 0 is less than n I plus plus and j is equal to 0, j is less than n, j plus plus. Now I want all this. This is I minus 1 j minus 1. 2, 2, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8. 10 to the power 8 is not good, right? So let's say this element. Subtract this, subtract this, subtract this. Let's think. Let me think. See, unless and until we are not getting wrong answer, that means we are going good. Oh, same. Local maxima is greater than x. Cell has a value greater than x. Okay, the same value, then also it's not an issue. Okay, okay. But how this pattern is forming, that is what concerning here. Let x is the value, let's say 2 is the value. Consider every cell within x row, within 2 rows and 2 column of row, within 2, 1 2 1 2. Okay, 1 2. Ignore cells that are outside the matrix. Which matrix? This cells. Okay, ignore the cell where both the rows distance and the column distance are x, exactly x. 1 2. Okay, caught it. Yeah, if you look at the distance 1 2 and 1 2, it is 2 or the distance is 2 comma 2 for all these rows. Okay, got it. Now we have to check this number is greater from all of the others. So brute force won't work here, right? Because if you look carefully, then it is n square, and again need a n square. I iterate from here to here. N to the power 4, and n is this 200 to the power 4. It's 200 into how much it is? 1 2 4 1 2 3 4 5 6 8 is 10 to the power 8 into 16 into 10 to the 1. That is 1.6 into 10 to the power 9, which is of course not a acceptable solution. So what we can do, can we do this check in order of n? How we can do it in order of n? Hmm. Okay, this make me feel think. What we can do here is we want some kind of check that tell us we can use some kind of prefix, right? Let's say this big. What is the maximum value of this? No, what we can do is we first take out the maximum value of this. But it is not feasible, right? How many checks we can make at a time? Hmm. Constraint is pretty low, then we have to think accordingly. I can go n cube, right? That is 10 to the power 6 into 8. Yeah, this is feasible. N cube is feasible solution. What we can do then? No, I don't want to fill. If this element is non-zero element, to do something here and increase the answer. People are solving. Let me read this question. Smallest unique subarray. You're given an integer array nums. Find the minimum length of subarray that is not identical. Not identical to any other subarray in nums. Return an integer denoting the minimum possible length of such a subarray. A subarray is a continuous, ठीक है. Two subarrays considered identical if there is the same length and the element as. Okay. We need a subfrequency of all the subarray. And all the subarray can grow up to n into n plus 1 by 2. Right. Oh. Constraint is pretty obvious. So we have two questions. Why? We have two questions now. One is constraint is small. I have to come up with an approach. Another one is constraint is good. We come up with an optimization. Optimization can be here. Mhm. What better we can do instead of brute force? That's what I'm thinking. What better we can do instead of brute force? How many people solve this question? 350, 380 per second, 30 user is solving. No, no, that's not. Thank God. What we can do here is then get the maximum. Get the maximum. No, right? Or mm, 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 I'm thinking is mm, I'm standing at some point. I want to know if I'm standing at the point is maximum. Should be like as a mountain. So what we can do is instead of checking all the possible candidate, we'll check from me how far is the greater element from me. How nearest? Yeah, this is what we can do is right. Yes, this is what we can do is so somehow we need to store for each point what's the nearest element. But how can we do that also? That's the big question here. Uh, how? Oh, it's just 200. Oh, got it, got it. It's a 200 only, right? Hmm. What I'm thinking is, say, if it is a x, then I go for the next greatest element. Let's x plus 1. Check where it is present. But won't that be a brute force also? Wasn't that a brute force? What we can do is, for each element, we add, let's say we have n square element. Oh, that's not a brute force actually. So, one quick thing in my mind came is unordered map of int comma vector of int comma int mp mp of matrix of I comma j dot push back comma j. Okay, let's not even make it, let's make it vector. Where vector dot push back this matrix of no, not this. Okay, return 0 for a minute. Vector of pair it should be. Okay, cool, right? Okay, so now we create a vector of this thing. Okay, let's say v for auto ampersand x or mp v dot push back x dot second. Okay, now we want to do like this. Let's say size is equal to v dot size and we have to look all its greater element, that is I plus 1 less than s g plus plus. Okay, so here what we have to do is this is x and this all are x plus greater than x. If this person lie in the surrounding of this, then this is not a potential answer. Hmm. So actually it should be like this: for auto ampersand x over v of I. Okay. Now this is this. Okay. Now here for this point, for auto ampersand y over v of j, for all this point I need to check. Let me make a bool okay is equal to true. So what we are going to check here is, does this 2 point lies in this area? If yes, then this is not a maximal. Okay, yeah. So let's say, so what is the boundary? Current I, no, current xi is equal to x dot first, xj is equal to x dot second, new xi is equal to y dot first, new yi is equal to y dot second. Okay, now I need to check this new y. If new xi less than equal to xi plus okay, it's a pair, right? We need this element also now. First comma second. Okay, radius is equal to okay. 1 2. What's the difference between them? I minus 1 j plus 2. I comma j. This is I minus 1 j plus 2. I minus I plus 1 plus j minus j minus 2. 1 plus it's a 3. Okay, it's a 3. Okay, that is okay, is greater than xi minus r and less than xi plus r and okay, and then new xi xy greater than equal to xj. New xi is greater than equal to xi minus r and new xi is less than equal to xi plus r. Minus means this, plus means this. New xj is greater than equal to xj minus r and new xj is less than equal to xj plus r. And what's this point? It should not be a corner point. How can I get a corner point? Is I comma j. This is I mine. All the four corners. Mu xi is not equal to xi minus r and then nu xi is not equal to x, and this is j is not equal to minus r. First point. Second point is plus. So new xi is not equal to xi plus r, and new xj is not equal to xj minus r. Second point covered. This is new xi is not equal to xi plus r, and new xj is not equal to xj plus r, and new xi is not equal to xi plus r, and new xj is not equal to xj plus r. Then ok is equal to false, and we have to break out here. Break. Okay. If not okay, break. Let me bring one step back. We'll break out of this for loop. We'll break out of this for loop also. And here, if okay, answer plus plus. Let's say answer is equal to 0. Oh, SSUND. Second. And this is it's v of I dot first. Okay, this is not good. Okay, if r is equal to 0, continue. Okay, 1 is fine, 2 is not fine, 5 is also fine. 2. Okay, can debug this. Let's debug this. 1 2 3 4. Currently cout r1 is equal to r, And the second point we are looking at is R2, that is this first. 1 2 3 4, 2 का 3. Wait. For 1 we have looked for 2 3 and 4. For 2 we only look for 3. Why we haven't looked for 4 here? That's the main concern. Okay, if answer is 0, 2 we get answer is 1. 1 2 3 4. 3 is there, right? Only the cell value 4 is the local maximum. Why one not? Okay. Ignore cells that are outside the matrix. Ignore the cell where both rows and distance column are exactly uh exactly x. This looks good to me actually. This looks good actually. 115. Can we let me test. Let me make it 2 here. What we are getting now is 3. Let me check. We have 1 2 1. We have 0 1 0. We have 1 0 1. This is valid. This is valid. Wait, it should be 2 instead of 3, I guess. This is not valid. It should be 2 here in this test cases. Let's print. For 0, we are checking for 1 and 2. 0, we had continue, right? Let's not print this then. Hmm. For 1 we are checking 2. Okay. So what we did is, the fuck it is. Let's not print here. Let's print here. Hmm. For this one we find out this. Wait a minute. Ah, got it. What's happened now is, what is this? 0 0 0 1 2. Then why we are getting this, or from where we are getting this? Okay. This follow, right? This follow. They haven't went inside. Ah, why I'm getting this? One. There are one, two, three, four, five, right? This is one, two, three, four, five. Then why this? Why we have six value here? Wait, let me think why we are printing six value here. This is loop. What's the size? Okay, size is 5. Okay. No, this is not true. Size is 5. 1, 2, 3, 4, 5, 6. Size is 1. Oh, this is for 2. Sorry, my bad. 1, 2, 3 is a fucking time wasted a lot. 3 is the correct answer. 3, 1, 1. Let me submit. We got AC here also. I wasted a lot of time just to debug. But it's fine. At least we didn't get any penalty, right? But penalty should fine, right? I wasted more than. No, I haven't wasted. Like, if I wasted more than 5 minutes just to check my answer is correct or not, instead I can get one penalty, right? That's also not bad. Today we have. See, I have improved. How? Because in last contest, if I show you how many wrong penalties I did. So today's contest target is just to get AC without any penalty. If I show you the last contest, see, four fucking penalties here and three the total seven penalties. So according to the penalty, I did pretty well. Okay, I can take it this as a compliment. Oof, it's a nice implementation question. Go for fourth one. See, here we need to come up with an optimization. Obviously, will not go one by one sub arrays, right? Eventually, that lead to a time limit exceeded because there is more than n square sub array, n square sub arrays, right? So, and n is this. So, what we can do is we can eliminate or not, or what we can do is we can do binary search. What's the maximum length of a sub array? What's the maximum length of sub array? Huh. What's the maximum length of subarray whose frequency is greater than 1? This is monotonic, right? This statement is monotonic, right? Hmm, I think this state we can do some kind of binary search on length, binary search on answer. Let's say my current answer is X. Do I have subarrays of length x whose frequency is greater than equal to 1. If I have, then I look for better. Do I have x plus 1? And what is the check? Can we effectively check order of n or n log n? Sub array, right? And I want to check that sub array is present or not in log n time. Don't say there are 1.5 all kill. Why, if people solve this question, this many users has solved this question, then this many all kill, right? But we saw only 372 all kills. How is this possible? This is looking something like, yeah, is human is not AI generated AI, right? See, 6 7, this kind of stats look, see, we start getting wrong answers. So this feel like, yeah, human is coding, not AI we are not competing with AI. See how LLM is doing here. Okay, LLM is doing pretty good here. That's fine. But 12 minute, can we even come up with an algorithm? It's fine if we're not able to code it in this time period, but do I know, like, does is I'm in the right direction or not? That is what I want to know. If I get binary search, see, concept is right, but the check we need, right, for each uh, possible candidate, we need a check. Let's say we are standing at here. Does this x satisfied or required? Requirement is there any sub array whose length is x and whose frequency is greater than 1? So we need this check. So there is something called persistence. We'll go through all the sub arrays and check its frequency. Yes, this is doable. It's also order of n, and the check is no. To populate that segment tree, to populate that data structure, we need to traverse all the subarray, and that is itself n square. No, this is not correct then. So this is all about today's contest, and yeah, it's pretty good contest in term of I can solve this question better, faster, but it's fine. I'm happy with the performance. This performance. We'll get around 3K rank. I hope. See, this is what I'm talking about. This is what I'm talking about. No, this is not good. It hurts, but it's fine. Anyway, we are not competing with AI, we're competing with humans, right? So yeah, this is all about today's contest. That's all. Bye bye. Thanks for watching.